close. So in Part 2 of Section 8.1, we're going to again look at the confidence intervals for population mean and a standard deviation that is known. So our objectives is to describe the relationship between the confidence level and the margin of error. Find the sample size necessary to obtain a confidence interval of a given width, and distinguish between confidence and probability. So our first objective is to describe the relationship between confidence level and the margin of error. If we want to be more confident that our interval contains the true value, we must increase the critical value, which increases the margin of error. There is a trade-off, however. We would rather have a higher level of confidence than a lower level, but we would also rather have a smaller margin of error than a larger one. So as you can see, the three levels here, at a 70% confidence level, although the margin of error is smaller, they cover the population mean only 70% of the time. At 95% confidence level, this represents a good compromise between reliability and margin of error for many purposes, and it's commonly used, and in this case 95% of the confidence intervals typically cover the true value of mu under this method. Under the method where we describe a confidence level of 99.7%, they almost always succeed in covering the population mean, but in this particular case the margin of error becomes pretty big. The diagram represents 100 different 95% confidence intervals. When we construct confidence intervals with level 95%, we are getting to a look at one of these confidence intervals. We don't get to see any other confidence intervals, nor do we get to see the vertical lines that indicate where the true value of mu is. We cannot be sure whether we got one of the confidence intervals that covers mu, or whether we were unlucky enough to get one of the unsuccessful ones. What we do know is that our confidence interval was constructed by a method that succeeds 95% of the time. The confidence level describes the success rate of the method used to construct the confidence interval, not the success of any particular interval. So now we want to find the sample size necessary to obtain a confidence interval of a given width. So in many experiments, typically we have to calculate the sample size first based upon what we believe to be the best margin of error. So we can make a margin of error smaller if we're willing to reduce our level of confidence. But we can also reduce the margin of error by increasing the sample size. If we let m represents the margin of error, then m equals the critical value times the standard error. So using some algebra, we may rewrite this formula as n, which equals z times sigma divided by the margin of error, and all of this is squared, which represents the minimum sample size needed to achieve the desired margin of error m. If the value of n is given by the formula is not a whole number, it is always round up to the nearest whole number. By rounding up, we can be sure that the margin of error is no greater than the desired value m. So a scientist wants to estimate the mean weight of mice after they've been fed a special diet. From previous studies, it is known that the weight is normally distributed with a standard deviation of 3 grams. How many mice must be weighed so that 95% of the confidence intervals will have a margin of error of 0.5 grams? Since we want a 95% confidence interval, we use z is equal to 1.96. We also know that alpha equals 3 and mu is equal to 0.5. Therefore, n in this particular case, when we put in the information into the formula, we get n is equal to 138.3 samples. But you can't get a 0.3 samples, so we always round up to the higher level, 139. We must weigh 139 mice in order to obtain a 95% confidence interval with a margin of error of 0.5 grams. Objective 3. Distinguish between confidence and probability. Suppose that a 90% confidence interval for the mean weight of cereal boxes in a previous Part 1 example was computed to be between 20.12 ounces and 20.38 ounces. It is tempting to say that the probability is 90% that mu is between 20.12 and 20.38. The term probability refers to a random events which can come out differently when experiments are repeated. The numbers 20.12 and 20.38 are fixed under this method, not random. The population mean is also fixed. Even if we do not know precisely what the value is, the population mean weight is either between 20.12 and 20.38 or it is not. Therefore, we say we have 90% confidence that the population mean is in this interval. On the other hand, let's say that we are discussing a method used to construct a 90% confidence interval. The method will succeed in covering the population mean 90% of the time and fail the other 10% of the time. Therefore, it is correct to say that the method for constructing a 90% confidence interval has a probability of 90% of covering the population mean. So, in this chapter, you should know how to describe the relationship between the confidence level and the margin of error, how to find the sample size necessary to obtain a confidence interval of a given width, and the difference between confidence and probability. That concludes our chapter 8.1. The next section that we're going to be covering is 8.2, proportions.